Welcome back, everybody. Today we're going to do a deep dive into something pretty cool, Amazon Trainium. It's AWS's custom chip designed specifically for AI training, and we've got a lot to cover. We've got technical specs, we've got customer stories, and even some insights into how it stacks up against the giants like NVIDIA. So
Yeah.
I'm really excited to go beyond just the what of Trainium and really dig into the why. Why does this matter, and what could the impact be?
Well, you hit the nail on the head there. It really is about more than just the hardware. Trainium is a sign that these really powerful AI tools are becoming more accessible, and that has huge implications for all kinds of industries.
Okay, so before we get ahead of ourselves, let's back up a bit.
Right.
What exactly is Trainium?
So at its heart, it's a chip that's purpose-built for one thing, training AI models. It's not about running those models once they're trained. That's where AWS Inferentia comes in.
Oh, okay.
Okay.
So they've got a specialized chip for each stage of the AI lifecycle that's smart.
Exactly. And with Trainium, we're talking about training the really big complex models like the large language models and multimodal models, the kind of AI that's pushing the boundaries.
And there are two generations, right? Tran 1 and Tran 2.
Yeah. You got a Tran 1 launched back in 2022, and then Tran 2 came out late last year.
And what's the big difference between the two?
Well, Tran 2 is a whole different ballgame, especially when it comes to generative AI. It's actually 4 times more powerful than the first generation.
Whoa, 4 times. That's a massive jump. So what makes Tran 2 so powerful? What's going on under the hood?
Well, each Tran 2 chip has 8 NeuronCore V3 processors. Think of those as specialized processing units built specifically for AI tasks.
Okay, so each core is pretty powerful on its own,
Hmm,
but I'm guessing there's more to it than that, right?
you're right. The real magic is how these cores work together. Tran 2 has this feature called Logical NeuronCore Configuration, or LNC, and it lets you combine the processing power and the memory of multiple neuron cores into a single unit.
So instead of 8 separate cores working independently, you can kind of create a super core by merging them.
Exactly. That flexibility is key because it means Tran 2 can handle much larger and more complex AI models than was possible before.
That's pretty impressive. But I'm always curious about the practical side of things. What does this actually mean in terms of performance?
So imagine you're training a model that used to take weeks to train. With Tran 2, you could potentially train that same model in just a few hours.
Okay, now that's a game changer. Time is money, especially in the AI world where things move so fast.
Absolutely. And it's not just speed. Tran 2 instances also have a whopping 1.5 terabytes of HBM3 memory. To put that in perspective, that's like having an entire library of data instantly accessible to the processors.
Wow, that's a lot of data.
Yeah.
What about situations where even a single Train 2 chip isn't enough? Like if you're working on some massive AI project.
Well, for those scenarios, AWS has these things called Tran 2 Ultra servers. They're basically supercomputers that connect 64 Trainium2 chips together, so you can scale your training to a whole new level. 64 chips? That's insane! It's like an army of AI specialists all working together in perfect sync. I'm starting to get why people are so excited about Trainium. But what makes it different from just using a bunch of really powerful CPUs?
That's a great question, and it gets to the heart of why Trainium is so innovative. There are a few key things. First, there's the high bandwidth memory we talked about. It's like having a superhighway for data to flow between the processors and the memory, and that's essential when you're dealing with these massive AI data sets.
Makes sense. Data is the lifeblood of AI, so you need a way to move it around quickly and efficiently. What else?
Then you've got NeuronLink. It's a dedicated high-speed connection that lets the Trainium chips communicate with each other super fast. It's like a private network just for the AI processors to coordinate their work.
So it's not just about the power of each individual chip, but about how efficiently they can all work together. Exactly. And don't forget about the specialized engines built into Trainium. They're designed to accelerate specific tasks that are common in AI algorithms, like matrix multiplication. It's like having a custom-built tool that can do these operations way faster than a general-purpose CPU.
So it's like Trainium is a finely tuned race car built for speed and efficiency from the ground up.
You got it. And the results speak for themselves.
All right, I'm sold on the tech, but what about the human element? Are there any cool stories about how real companies are using Trainium to make an impact?
Oh, absolutely. Let's start with Anthropic, the company behind the Claude language model, which some say could even rival ChatGPT.
Oh yeah, I've heard of Claude. It's supposed to be pretty impressive.
It is, and they're using Trainium 2 to train it. Not only are they seeing big performance gains, but they're also saving a lot of money. And then there's Itaú Unibanco, a huge bank in Latin America.
Hold on, before we get to more examples, I want to go back to something you said earlier. You said that Trainium is a sign that powerful AI tools are becoming more accessible. Can you unpack that a little? Why should our listener care about that?
It's easy to get caught up in the technical stuff, but the real impact of Trainium is much broader. Faster training times lower costs means that developing AI isn't just for the big tech companies with tons of resources anymore. Smaller companies, research institutions, even individual developers can now access the tools they need to build and train these really sophisticated AI models.
So it's like Trainium is democratizing AI, putting the power in the hands of more people.
Exactly. And that has the potential to really accelerate innovation across so many fields. Think about breakthroughs in medicine, climate modeling materials, science, you name it.
That's pretty exciting. But I have to admit, training these massive AI models sounds incredibly complex. How do developers even manage all that?
You're right, it can be a real logistical headache. Imagine trying to coordinate a team of thousands all working on different parts of the same puzzle. That's kind of what it's like to train a huge AI model across multiple chips and servers. It's called distributed training, and it's one of the biggest challenges in AI development.
So how do they solve that?
That's where AWS SageMaker Hyperpod comes in.
I've heard that name before, but I'm not totally sure what it is. Can you break it down for us?
Sure, SageMaker Hyperpod is a managed service from AWS that basically simplifies distributed training. Think of it like an orchestra conductor, making sure all the instruments are playing together to create this beautiful symphony. It handles all the complicated infrastructure stuff so developers can just focus on the AI itself.
So instead of getting bogged down in all the technical details of managing a massive training setup, developers can focus on the creative and scientific side of building their models.
Exactly. And that's a game changer for AI development.
Okay, I'm getting a much clearer picture of how all these pieces fit together. Now, I'm really curious to hear about those real-world examples you mentioned earlier. Let's start with Itaú Unibanco, the bank you were talking about. How are they using Trainium?
They're using it to analyze financial data, and they've seen a 7x performance boost for certain tasks compared to using GPUs. That kind of speed can make a huge difference in their ability to detect fraud, assess risk, and make better decisions.
Wow, 7 times faster. That's incredible. What about other industries?
Well, there's RCAI. They're using machine learning to develop personalized cancer treatments, and they've managed to reduce their model training time from 17 hours down to just 1.6 hours using Trainium.
17 hours down to 1.6 hours. That's like finishing a whole work week in less than a day.
You got it. And that kind of time saving can have a huge impact on their ability to develop and actually use these life-saving treatments.
It's clear that Trainium is already having a big impact. But now I'm wondering how it stacks up against the big names in the AI chip world, like NVIDIA GPUs and Google TPUs. That's a question we'll explore in our next segment. So we've heard about all the amazing things Trainium can do, but how does it actually compare to the big names out there, like NVIDIA and Google?
That's the million-dollar question, and it's not a simple answer.
But that's what makes it interesting, right?
You got it. When it comes to raw power, NVIDIA GPUs are still a major force. They've been in the game for a long time, and their software, especially CUDA, is really well developed and widely used.
So where does that leave Trainium? Is it playing catch-up in the software department?
They're catching up, and they're doing it fast. The Neuron SDK, which is what developers use to work with Trainium, is open source, and it works really well with popular machine learning frameworks like PyTorch and TensorFlow. Plus, AWS is putting a lot of effort into expanding that ecosystem.
Open source is always a good sign. So if NVIDIA has the edge in software, where does Trainium really shine?
Two main areas: cost effectiveness and scalability. For certain jobs, especially large-scale training, Turn 2 instances can be significantly cheaper than similar GPU-based instances. And with the ability to build these huge Trainium clusters, you can tackle problems that would be incredibly expensive or even impossible with GPUs.
So it sounds like a classic trade-off: NVIDIA for performance and a mature software scene, Trainium for cost effectiveness and the ability to scale up. What about Google TPUs? Where do they fit into all of this?
TPUs are incredibly powerful, no doubt, but they have a big limitation. They only work within Google's cloud platform.
So if you're already all in on AWS, TPUs aren't even an option?
Exactly. It really highlights how choosing the right AI accelerator comes down to your specific needs and what you prioritize.
And it's exciting to see so much variety in the market. Competition is usually good for innovation, right?
Mhm.
Everyone benefits from having more choices.
Absolutely. And speaking of competition, it's interesting to see that so many big tech companies are making their own AI chips now. Amazon with Trainium, Google with TPUs, Meta with their own custom chips. Everyone's getting in on the action.
Is there a reason for this sudden surge in custom AI chips? Or is it just a coincidence?
It's definitely a trend, and there are a few factors driving it. One is cost control. These companies are running massive AI operations, and using chips from other companies can get really expensive. Designing their own chips gives them more control over their costs and ensures a steady supply.
Makes sense. What other reasons are pushing this trend?
Optimization is a big one. These companies have very specific needs and workloads, and they can design their chips to be perfect for those tasks. It's like having a tailor-made suit. It just fits better.
So it's all about gaining an advantage in the AI race.
Exactly. AI is becoming the heart of everything these companies do. It's what sets them apart. So having the best possible hardware is crucial.
And that brings me to something I found interesting about Trainium. AWS's commitment to open source.
Yeah.
Seems like a pretty big deal.
It is. The Neuron SDK is open source, and they have this program called Build on Trainium, where they're investing $110 million to support research and education related to Trainium.
What's the strategy behind that? Why share their technology so openly?
It's about fostering innovation and building a community around Trainium by making the tools and resources easily accessible. AWS is encouraging developers to experiment, create new applications, and push the boundaries of what's possible with AI.
So it's not just about building a better chip, but about building a better AI ecosystem as a whole.
You got it. It's a long-term strategy. The more people using and developing for Trainium, the more valuable it becomes. And that benefits everyone in the end.
Okay, I'm starting to see the bigger picture here, but before we wrap up, I want to touch on something that's been on my mind throughout this whole discussion. The potential impact of all this on the world. Faster AI training, more powerful AI models. It feels like we're on the edge of something truly transformative.
You're absolutely right, and that's what makes this technology so exciting, and maybe a little bit daunting too. The possibilities are huge, but we also need to be aware of the potential challenges that come with it.
What kind of challenges are we talking about?
Well, think about it. As AI systems become more sophisticated, we need to carefully consider their role in society. How do we make sure they're used for good and not for harm?
Those are some really important questions, and I don't think there are any easy answers, but they're questions we definitely need to be asking as we go deeper into the world of AI.
Absolutely. This is a conversation that needs to happen at all levels, from the developers creating these technologies to the policymakers who will be responsible for regulating them, and of course the public needs to be informed and involved too.
Well said. It's clear that Trainium is more than just a piece of technology. It's a starting point for a bigger discussion about the future of AI and how it will impact our lives. And with that, I think it's time to move on to our final segment, where we'll explore some concluding thoughts. It feels like we've only just scratched the surface of what's happening in AI.
Yeah, we have, but that's what makes this field so exciting. It's always evolving. What's cutting edge today might be old news tomorrow.
That's why I think deep dives like this are so important. We need to keep learning and keep having these conversations.
I agree. And for me, one of the most exciting things is seeing the potential for democratization. As these AI tools become more powerful and easier to use, it opens up so many possibilities for people who couldn't compete before. You know, individuals, small teams.
So it's not just the big tech companies playing in this space anymore.
Not at all. Think about researchers in developing countries, startups with limited budgets, even students who are passionate about AI. They can all use these advancements to make a difference.
That's pretty inspiring. It makes me think about how the Neuron SDK is open source and the Build on Trainium program. It seems like AWS is really trying to make AI more inclusive.
They are, and that's a really positive thing. By lowering the barriers to entry, they're creating a more level playing field and giving a whole new generation of AI innovators the tools they need to succeed.
So if we zoom out a bit and look at the bigger picture, what does Trainium really represent?
I think it represents a shift in how we think about AI development. It's moving away from relying on general-purpose hardware and towards specialized tools that are designed to really unlock AI's full potential.
And that potential is huge.
It is. We're talking about advancements that could completely change healthcare, revolutionize transportation, help us tackle climate change. The possibilities are pretty mind-blowing.
It's both exciting and a bit overwhelming to think about how AI will shape our future.
It is. But I'm optimistic, I think, if we approach it the right way. With a focus on ethics, fairness, and collaboration, we can use the power of AI to build a better world for everyone.
That's a great point, and I think it's a perfect way to wrap up our deep dive into Amazon Trainium. We hope you learned something new today, maybe gained a new perspective, and maybe even sparked some ideas of your own about the future of AI.
And remember, this is just the beginning. Stay curious, keep exploring, and let's all continue to shape the future of AI together.
Thanks for joining us, and we'll see you next time for another deep dive.